Our first talk is going to be by Henning Dieterichs, who's going to be talking about hacking the language service, implementing custom refactorings for TypeScript. So with no further delay, I'm going to bring Henning on board. Hey,
Hi.
Welcome, Henning.
Hi.
Are you ready to give your talk?
Yeah, sure.
Okay,
so
cool.
Thank you very much for joining my very first talk. I hope you are well in these crazy times, and I'm very happy to have this opportunity to share my knowledge about the TypeScript language service. But let me introduce myself real quick. So I would call myself an open source enthusiast. You can find all my work on GitHub, and I'm very much into programming language, Visual Studio Code, and developer experience in general. And currently, I'm doing my master's degree at VKIT in Karlsruhe. I'm also part-time employed at Knuddels, where I am responsible for the front-end architecture and the developer experience. So what will this talk be about? So hopefully you will learn how to extend the TypeScript language service by implementing your own plugin. I will do this by doing some live coding where we implement the structure code action as such a TypeScript language service plugin. And in doing so, we will work with the AST and the type checker. So let's have a look at how the Visual Studio Code IDE interacts with the TypeScript language service. So Visual Studio Code has this UI, which is an Electron process, and the extension host. And if you implement an extension for Visual Studio Code, it will be hosted inside this extension host. And there is this TypeScript extension that provides this TypeScript functionality like autocomplete, syntax, go to references, rename, and stuff like this. But this TypeScript extension inside Visual Studio Code only launches this TypeScript language service and communicates with it using the language service protocol. And this is really cool because this language service protocol is standardized, and other IDEs like Atom or Sublime Text can use this language service protocol too, so they don't have to redo all the work. So something like rename is implemented in this language service, and other IDEs can all use the same implementation. This is really great. Another cool thing is that we can extend this language service with custom plugins that are hosted inside this language service rather than just inside the extension host of Visual Studio Code. So if we would implement an extension inside Visual Studio Code, it will not work for other IDEs, but inside the language service, it will, which is really great. There are multiple ways to implement such a plugin. The easiest way is to just specify in the tsconfig.json, and I'm sure you're all familiar with the tsconfig file, which is used to set up a TypeScript project. And another way is, if you don't want to mention your extension, your TypeScript language service plugin, you can just implement an extension for Visual Studio Code that activates the plugin for you. So this is the basic architecture. Let's have a look at what we are trying to implement. So this is some TypeScript code. I hope you are familiar with TypeScript. And our goal is to extend this language service to offer a code action. If I have this cursor positioned here, I want to be able to destructure this expression. So let's start with this x here. X is an object that has these properties x1 and x2. And I want to have my code action produce this code so that x gets destructured, which is often really useful. And in case of this merge expression, which merges the objects x and y has this property y1, I want to destructure all the members because merge has both members here. And the result should be like this. So the goal is to implement a code action that has been suggested with a lightbulb, like we can see it here, but this lightbulb will suggest other things. And I want to suggest destructure, and it will lead to something like this. Okay, how do we do this? We will start actually with a completely empty folder, and we will start with a package.json file. And inside this package.json file, we set the name of our plugin, which is something you can choose, like my TS plugin. And you define the entry point, which is in the dist folder. We will set up that soon. And we need to add TypeScript as a dev dependency. So we can have the types. And let's just install the dependency by calling yarn. And now we can set up a tsconfig file for our plugin so that you can use TypeScript to implement the plugin itself, tsconfig.json. And it is set up to compile to dist, to the dist folder, and it will include all files in the source folder. And also, it enables experimental decorators, and it has strict null checks enabled. So let me create this source folder and this index file. So this is the basic structure. And I will now reload the tasks in the taskbar so that I have this watch task. And this will now transpile my source folder to this stuff. This should be pretty familiar. So this file then gets loaded by the language service, and it expects some structure here. So this is the basic template if you want to implement such a TypeScript plugin for the language service. Basically, it has a default export of an init function, and the TypeScript language service will then call this init function with the TypeScript API, and it expects this method to return an object that has a create function. And this create function gets the underlying language service, and you can return a new language service here. And this dummy implementation just returns the language service as is. So this is already a valid TypeScript plugin. How do we use this and how do we configure a project to use this plugin? If we configure it, we want to see something. And to see something, I implemented a pretty neat library. It's called EasyAttach. And with EasyAttach, you can attach to arbitrary node.js processes that execute this line of code. And for some reason, I have to specify the debug pod to be pre-configured, but this is not important. So when the TypeScript language service loads this plugin, EasyAttach will allow us to debug this process. And otherwise, it would be really hard to debug the language service. So let's go back to our Visual Studio Code instance where we want to use this plugin. And we now go to the tsconfig file where we have this plugins section. And there we can mention our plugin. So, and this expects our plugin to be in the node modules folder. Usually, if you want to deploy your plugin, you use like npm publish to host it, and then you can put it to the dev dependencies. But we don't, during development, we don't want to publish it every time on npm, so we use yarn link. With yarn link, I can just type yarn link in the plugin, and I can go back here and type yarn link my TS plugin, and it will create a symlink. So now I have my TypeScript plugin symlinked into this folder that where I want to use my plugin. So another thing that is really important, and you should not forget this, is you should select the workspace TypeScript version, and you should install TypeScript in your workspace so that the plugin gets loaded. This is for some security reason. But if you forget this, then your plugin will never get loaded. So now you can already see the plugin has been loaded and EasyAttach has been triggered. And if I switch back to the plugin, I can see here the debug node process button. If I click on it, Visual Studio Code will attach to this language service. And now we have this language. We are debugging basically our plugin that is hosted inside the language service. And this language service is used by Visual Studio Code to do various actions, like asking for which refactorings are available, how rename works, and all this stuff. And we can modify it here. We can actually decorate this language service by returning a new language service. And we can do this simply by using all the things that are already in the language service, and then we can override the stuff that we want to override. And to do this very easily, we just create a main class where we implement all our stuff. And in this main class, we will need this TypeScript object, this TypeScript API. So let me just declare it here, private read-only TypeScript, or let's call it TS, of type TS API. And it turns out, so we also need the underlying language service to do some stuff there when we implement our plugin or when we decorate it. So we have to inject this to our main class as well. Private read-only language service, which is of type, of course, just language service. Okay, that's it. And of course, I need to do type of TSAP here. This TS API is basically the local installed TypeScript API and has stuff like all the types and all the functions you expect if you just import TypeScript. But we shouldn't use this one. We should only use it for types because the TypeScript language service might use a newer version of TypeScript, a newer version than what we installed with our plugin. So we should only use the TypeScript API that has been provided by the language service. But we have to use TS API for the types. So we are injecting the type of TS API, but we have to use TS. Now, if we want to implement a code action or refactor, these are the two methods we have to override: get applicable refactors and get edits for refactor. Get applicable refactors will list all the available refactors, and get edits will return the edits for it. So let's delegate these two functions to our main instance, like this. I will copy this here. Like this. And we have to set up this main instance with the TypeScript API and the base language service. So these members don't exist yet, but I can use such a nice refactoring, which is hosted in the language service, to just declare these properties so that the types are all right. But also I have to bind this main because of JavaScript issues. And this should be pretty straightforward. We're just returning a new language service here that is basically the same as the existing language service. And these two methods we want to override. And in doing so, we allow access to the underlying language service. Let me convert these two properties to methods real quick, like this, and like this. So the first one, get applicable refactors, is expecting an array, and we are on the safe side if we, for the beginning, just return an empty array. And here, we can also return undefined, and we can just return undefined to test it out. And we can just report a debugger statement here to see what happens, and restart the entire stuff and see whether it works. So we don't need this line anymore. And let's restart the language service here and see what happens. So if we restart the TypeScript language service here, easy attach is being triggered again. I can attach to the process again. And if I switch now back and, for example, click on the merge identifier, Visual Studio Code already asks our plugin to get the applicable refactors. And here we can now do our stuff, like we can return something. And here we can put some description. This is required, and I don't really know why it's not being showed up anywhere. The more important thing is actions. Here we can list all the actions our plugin supports, like the structure stuff and the name. So the description is something that is displayed for the user, and the name has to be unique. Like you can make it unique by prefixing it with your vendor ID. So like this. So if I now continue, it will still return the old empty array. So it will not reflect this change I just made. So I would have to restart the TypeScript language service again. This is not so cool because we are doing a lot of change, and restarting it every time is not so cool. This is why I came up with a library that I called node reload. I'm just installing this library, and node reload is basically what Webpack hot reload is doing for web apps for Node.js. So I just installed it, and I'm now importing some stuff from node reload, like enable hot reload, register update reconciler, and hot class. So enable hot reload just starts the file watcher that watches all JS files when they are being updated by the TypeScript watch service that's running in the background. And the entry module is just module. And with register update reconciler, I say that it's fine to just reload this entire module every time it changes. So the really cool thing now is the hot class attribute. Because if I put this if I put this hot class attribute here like this, then every time I change a method, the method prototype is being updated. So it will always use the most recent body of this method. So in theory, this should be now the last time I need to restart the language service, because after then we can use hot reload. So restart TS server. Now easy attach should be triggered again. Okay, here it is. And now if we again let Visual Studio Code ask for applicable refactorings, like here, then we can see we undo the debugger statement, and I can just delete it and never be again there. And now every time, everywhere I click, this light bulb is displayed, and it suggests to destructure something, which is not really useful because now I can basically destructure anything. This is definitely not what we want. And if I click on it, it even doesn't work. So we have to fix this. So if you look at get applicable refactors and get edits for refactor, you see that both have this file name and position or range. Here, file name and position or range. All the other options are not interesting for now. So it turns out both these stuff are doing something similar. So we can just introduce a new method that is called getRefactor that just returns either our refactoring with some information. We have to decide what information we put there, or just undefined if the refactor is not applicable at this position. And the arguments are just the file name and the position or range. So and the thing that we want to return is just the name for now of the refactor. So like this. And by default, we just return undefined here to, or maybe it's better to, by default, suggest to the structure. Sorry, the structure. So now we are wiring up. We are calling this getRefactor method that we just introduced for this file name and position or range, and call this R. And if R is not defined, we will just call into the language service that we injected already to this main class, to the underlying language service. And we ask the existing language service which refactors it thinks are applicable at this position. And here we have to pass all the position or ranges and all the other arguments. If we don't do this, we will basically disable all the existing refactors. So otherwise, we use this R to get this description, and yeah, we use the same for the name in this case. I think it's fine. Okay, let's put a debugger statement here and see whether hot reload works and it gets triggered. So I click in here, and yeah, hot reload works, it got triggered, and now we can implement this get refactor stuff. So for our goal, we need to work with the abstract syntax tree. But how do we get the abstract syntax tree? And it turns out the language service, the underlying language service that we already get, has a function that is called getProgram. And it returns a program. And we can ask, so basically a program is a TypeScript project or TypeScript compilation. And this has a function, getSourceFile, where you can put the file name, and then you get the abstract syntax tree of this file name, if it is included in the project. If not, it's returning null. But in this talk, we are going to assume it never returning null. So this is the source file then. And a really nice thing about hot reload is that if we are debugging a method and changing the method while we are inside of it, if we step outside of it, it will be restarted automatically. So if I press F5, it will automatically be rerun. But now with the latest change. So now I have my source file here, and I want to visualize this abstract syntax tree. And for this, I implemented an extension for Visual Studio Code that can visualize arbitrary stuff, but it has a special case for syntax trees, for TypeScript syntax trees. Now here you can see the entire syntax tree of SF. And here's the source. If you click on a node, then it will highlight this node in the source. This makes it really easy to implement refactorings. So the first thing we need to do is we want to find the node at the cursor. The cursor is basically this position. So basically, we want to find the node at this column. And this is quite easy. We need a function that gives us the node at a given position. This is basically the smallest node. And get node at position. And it has a parent and TS API, and it will return the node, and it also gets the position. So like this, position is the number, and here we implement the stuff. So basically, we are iterating over all children of the parent, and if this child contains position, then we are returning. So if the position is between cpos and and, so we can't do it like this, we have to do it like this, then child is something that contains position, and we ask the same thing with C as the parent. Otherwise, we're just returning the parent itself, because no child apparently contains this position. So let's see whether this guy works. So const node at cursor is we get node at position of the source file as the topmost parent. And now we have to provide the position of the cursor. And we already have this position arranged, which can be, as the name says, a position arranged. So we have to deal with this. So if the type is a number, then it's the position, and we can just return the position. Otherwise, it's a range, and we need to we just return the start of this range. So node at cursor now is the node at cursor, and if I press F5, it got reloaded, and now we can see whether it worked. And actually, the node at cursor here is now this identifier where we positioned our cursor. Some cool thing here is if I remove this debugger statement and just let it running and enable polling here, and for this I have to do something here, little hacky, node equals node at cursor. And if I now watch node, the global variable, and poll it, and if I click at something here, it will always point to the thing that we are doing. So this is quite fun to play with. So like here, we're clicking on the identifier here and jump to there. Okay. Let's go back here. Now we have the node at cursor. In case of the merge identifier, we want to identify, let me disable polling. We want to identify the parent expression statement. So we have, if we click on merge and this one has been selected, we want to go up until we find this expression statement here. So we need another function. Let's call it get parent expression statement, and it gets a node again of this abstract syntax tree, and it returns an expression statement, or undefined if this node does not have a parent expression statement. So if we can ask the TS API whether a node is an expression statement here, and if it is, we can just return node, and otherwise, if node has parent, then we can ask the parent to return it, and if it doesn't have something, then we just return undefined. So, and the parent expression statements then would be get parent expression statement of the node at the cursor. And this, of course, let's call it like this. Let's put the debugger statement here again and see what happens if I click on merge again. Okay, this thing also allows me to visualize multiple things at once. It doesn't. I think, wait, this is weird. Of course, I forgot this return. Easy bug. Okay, it works now, and we can see how node at cursor relates to it. So this is the node at cursor, this expression statement, and now we want to find all the properties that this expression has, and we can use the type checker for it. So the type checker is also offered by the program, and the type checker we can ask, hey type checker, give us the type for this node, and we are asking it for the node for the expression of this expression statement. Now we have this type, and conveniently this type has a function get properties, and we can just map all the properties to the name. And if we do it like this, can now see props x1, x2, y1. This is for free. And now this part is so now we can do something like if props length is 0, then we don't want to suggest our refactoring at all. Okay, so this part already works. So now the structure is suggested every time it makes sense. So for ZX, for example, it doesn't make sense because it doesn't have any properties, but here it does make sense. But if you invoke it, it will still fail. This is because we haven't implemented getEdits for refactor. But this is very easy now. We can just call R again. And if not R, we should do something better than just returning undefined, like calling the underlying language service. But let's start, we don't need to do this. And otherwise, it would be cool if R has information of this refactor edit info, so that we can do just like this, edit info. So let's just add edit info to our result here. Edit info, refactor edit info. Okay, so we need to add the edit info here now, and everything will work. So basically, edit info is something that has some edits, and each edit that we can specify a file name, if we want to edit the current file name, and we can provide an array of text changes. And there we can replace a given span, and we don't want to replace anything. We want to insert it directly before this thing. So we are going to provide a span that starts where our parent expression statement starts. So like this, and the length will be 0 so that we don't replace anything. So basically here we can insert anything. And if I do it like this, it should already work because of hot reload. And if I do it like this, it will just insert this constant. This is not ultimately what you want, but the rest is easy now. So basically, I already collected the props. I can do something like new text. Basically, I want to have this object here and this here. This, and I want to suggest to insert the new text here. And here I can just use the properties I already have and join them separated with a comma. And this is it. If I now apply this refactoring, then it will destructure arbitrary expressions where the type system can figure out the type. Even if I do stuff like this, it will also consider this XYZ property, which is really cool. Yeah, now that we finished implementing our refactoring, do you have any questions?
We are now entering the Q&A phase. Let's see if any questions are coming in via the chat. And okay, so far we've had comments about if you can't follow, that's not because you're thinking too slow, that's because Henning is on fire. So Henning, thank you so much for the talk. And we have a question from Volker Brown. What's your favorite refactoring that VS Code doesn't come with?
I think it's inlining, because the inlining refactoring is super powerful and you can reduce many other refactorings to this. Yeah, like renaming, like reordering parameters, you can do this with inlining.
Right, okay. Well, on that note, we have the audience thanking you. Great demo. The rest is easy. So yeah, I'd like to thank you so much, Henning, for that insightful talk. And now I would like to, if you have any other things you want to say before we move on.
Yeah, one final thing. If you're interested in which tools I have used, like Visual Studio Code extensions, then you can find all the links on this slide. And thank you very much, too, for having me here.
Pleasure having you, Henning. Do you mind sharing the link with me so that I can post it in the YouTube channel, in the YouTube chat, to your slides?
Yeah.
So we will share that right after.
I can do this later, yeah.
All right. Okay, thank you, Henning.